Hey everyone, thanks for coming. This talk about using generative AI to design pixel perfect imagery for Godot engine and beyond. You can use its techniques for anything. Just a bit of background about who I am. I've been at AWS as a game tech solution architect for 3 years, 5 years at AWS, 10 years as a customer, but I spent 20 odd years in the world of 3D worlds and spatial stuff, and about the similar amount of time looking at machine learning techniques. I build a lot of my own music instruments. I pull machines apart. I JTAG into old retro handheld machines. I do the launcher for all of those devices called Esoteric. I make a bunch of records. I think Discogs has got me at 20-something albums now and a hell of a lot of tours. But what I'm really is a terrible, truly bad artist, and I'm all fingers and thumbs like a 2022 AI image generated hand. We did this session in 2002 for Canon down at La Défense in Paris, where they wanted us to build a fish tank, interactive fish tank for an exhibition across 18 screens. And we demoed it, we built it. There's pressure mats to detect where people were, because this is what the technology was at the time. And when we pitched it to them and we did the POC, we said, we'll show you we can do it, but not what it looks like. Don't think about what it looks like. They're like, we don't care what it looks like. Show us you can build 18 screens, fish tank that surrounds people with fish going around it and paying attention to people if they stop and look at them. And we built it, we used OpenCV, we were using hard classifiers, sort of real state-of-the-art stuff at the time, and we did it in a boxed-out style. And when we showed it to them, you can see their faces just fell because it was boxed out, and you only get that one chance to make a good impact, and that sort of stayed with me ever since. And so give me some curly brackets and I can kind of build anything. Give me a guitar or whatever, and like, I'm happy, off we go. But I can't get, or until recently, I've never been able to get from that icky thing on the left up to something that I'm not sort of embarrassed about, or that I can convey to people or get across to people, prototype with, inspire myself perhaps. And every time you work with an artist, you sort of have this fidelity loss when you're trying to explain, when you're as inept as I am, that what's in your head, you have to sort of put it into words, get the words out of your mouth, in through their ear hole, into their brain, into their reference centers, and out through the tools that they use. And you sort of go around this, and every single step of that is a fidelity loss. And so even if you're just looking at trying to bring something to people to be a starting point and a jump-off point to show what you're thinking, I think this technique can go a long way towards prototyping really fast, because this bar of expectation has been raised so high lately that it has to look good out of the box. And so today we're going to talk about how to go from icky to R, and we're going to cover very quickly what changed in tech to enable this, things like the intro of Stable Diffusion, ControlNet, Automatic 111 UI. And then we're going to jump into looking at setting up Godot for pixel perfect platformers, how to create templates, and this is kind of an important part of it, and this is very portable. And then how to set up the entire tool chain, quick demo showing the end-to-end of this, and then sort of tips that I learned along the way of doing this, sort of spending a year working on this process. And the first bit of tech that came along was the diffusion models, and I'm sure there's anyone here, I'm sure some of you have used Midjourney. Anyone here played with Midjourney and DALL-E? And yeah, great. So Midjourney came along, and the internet got busy generating like 1 million anime pictures and underdressed Valkyries and all of those things. And people made images and showed them to their friends and then filed them in an awkward folder of, we don't know what to do with this, we shouldn't delete it. But it scratched an itch, and then you move on. The idea behind it, though, I think is becoming more and more adaptable since the Stable Diffusion came along, because it's open and you can build all of these extra layers on top of it that can fold into your processes. And that's kind of the first building block that happened here. And let's talk very quickly about how they work so we can understand the components, how they fit together. So when you experiment with this, you know roughly what you're doing. And you can sort of achieve good results out of the box. So you start off with a labeled image, and that labeling is really an important factor, and we'll come back to that later on. And what happens is we flow through a Markov chain. Characteristics of a Markov chain is it's forward only, and each step in the Markov chain is only dependent on the previous time step. There's no other impacts on this. And at each step, you just add some noise. It's Gaussian noise. It's got a normal distribution, which is this bit here. And what it's doing is it's shifting the pixels around, and it's shifting around in a kind of predictable manner, like predictable random. And we do this for like 1,000 steps, and we end up with pure noise at the end of it. And this is the first part of the diffusion process. And it gets its name from the diffusion of like dropping ink in water or something like that, and it's slowly Brownian motion sort of carrying it out. So what we need to do is actually, from a noise input, is reverse the process, which is kind of the interesting part of what's going on here. And we use a convolutional neural network for this, and it's a regularized type of feed-forward neural network that learns feature engineering by itself via filter optimization. And they're very good at pattern recognition. This is the important part of this. And the CNN we use in Stable Diffusion is called UNet, and it's called that because of the shape of it. And what happens is that at each stage, it reduces the image space down and simplifies it like a compressor kind of thing. And it takes some discrete actions on it, like edge detection, basically matrix transforms, looking for edges, looking for dominant shapes, colors, things like that. And the horizontal lines at each section allow it to keep the overview of what the entire structure should look like. And this is what gives it its stability, that it will process smaller components, but it will also merge those with the higher level text input that you give it. So that's the first step that came along. We kind of put it together into a pipeline. And for training, we start going through an encoder. Then we use the UNet, CNN that we just talked about, and a decoder, and out pops an image at the other end of it. We don't really need the encoder for text to image stuff because our prompt is text, right? So we just start from pure noise. But it's very useful for things like in-painting, out-painting, image to image, etc. But the text part, we're using an NLP flow, which is stemmer, lemma, tokenizer, encoder, and then turn it into an embedded vector space. And this is the same that we do when we do the training as well, and all of the images are labeled, and this labeling goes through the same pipeline, and then you can compare vectors and work out the noise reduction that you need to do. And the last part of this, then we get back to normal stuff, is ControlNet. And the way ControlNet works is that at each step of the UNet pipeline, you have one of these segments here. You have the Stable Diffusion model that is locked off and it's read-only, and this is what, again, gives ControlNet the stability to keep the idea of a big composed image in its mind. And then a trainable copy, and this will be the bit that is influenced by the controls that we put on it. And the pre-processing steps of ControlNet that take an image and turn it into something that is repeatably reliable comes out of the box with these kind of preprocessors. So there's the original there. Segmentation one takes you down to a very low dimensional representation of any image. It's very nice if you bring your own complex imagery to start with, and it will reduce it down to something where you can then use another stage like soft edge or scribble. Depth is exactly what you think it is. It's the same depth processing that goes on in an earth. Normals is bringing out the 3D normals. Line art, canny, soft edge, and scribble are kind of the most interesting ones for generating this stuff reliably. And what they let you do is combine ControlNet with Stable Diffusion, and you end up with filtering a soft edge, a vectorized prompt that feeds into the noise starting point. And these two things go round and round and reduce the noise until they get something like, if you put, what was it, fish or dog or cat or whatever. I mean, I make a pretty weird looking fish, but pretty weird looking human as well. So, but this is the combined thing, is you get these two controls going in that no one else can do, like Midjourney, whatever, they're sort of closed boxes. Stable Diffusion allows you to do different things like this, and this is the control part of it that lets us actually tie things pixelated back to our Godot game, and we're going to get to that in just a second. The last component on the ML side is just the UI that came out, and it's been kind of the de facto source of stable diffusion manipulation. It's called Automatic 111. There's going to be links at the end, but there's also a code repo that has all of these links in it and all the credits for all the things that we're talking about here. It handles more than text to image. That screenshot is the default text to image one. You type your prompt in. It does image to image, inpainting, outpainting, all kinds of functionality as well, but we're looking at a reasonably simple journey here. And that's kind of everything on the ML side. So we just had a very whirlwind tour of how stable diffusion works, how control-net works at every section of the flow of the convolutional neural network with SD, and the UI to wrap it all up and let us interact with it simply. So now we're kind of onto the Godot side of things. There's three real areas to look at in terms of making something pixel perfect without anti-aliasing, etc. in Godot. You want to target something that avoids subpixels, ideally like 640 by 360 or a 720p, 1080p, something like that. I purposefully didn't here. You'll see it's just random numbers because the demo is to show you, and the example project is to show you the unhappy cases and how it still works with that as well. It's easy doing 512 by 512. Stable's very happy there, but you can get it to go beyond that as well. You can set the width and height overrides if you need to make, like, basically pinch and zoom. Canvas items, and for the stretch mode is the one you want. It's the viewport's resolution is divided by the scale on that one. This makes pixels look a bit larger and can reduce rendering resolution if you're doing if you're trying to avoid aliasing. And then finally, there's the aspect ratio, and there's different options. There's like keep width, keep height, and they choose whether you get black borders, side, top, bottom, or best fit. Keep is the simple one to go for there. And once you set these sections up, the next part is just the rendering and the snap. Snap is doing exactly what it looks like. These are off by default. You want to transform and put all the vertices into pixel position and lock them in there. And the very important one of all is the default texture filter. Set that to nearest and you won't get aliasing at all. So that's kind of the setup of a Godot for a pixel project. The next part of it, and there's no compression algorithm for experience, as we always say. And designing your level is going to take time, right? It's a very fine, precise thing. There is no way to get around that. Things that I would say about this that I learned along the way: put everything in layers, put your background inanimate structural tiles in a layer at the background and build forward from that. Have your collapsible things, have your moving aspects, put them in forward layers and sort of Z-index forward from there. And the reason for that is that we're going to create a template in a minute, and for that you only want the static objects. So layers are your friends here. We'll also talk a little bit about modulating stuff automatically to fit into the generated levels. And again, the layers are your friends here. So yeah, definitely a nice tip on that one is use the TileMap layers. So the core bit to bring a pixel level map into stable diffusion is to build a template, and this template is the thing on the left over here, and it's a super ugly lo-fi rendering out of what we've built, just the background layers. And things you want to do here is put it on a black background rather than anything else. You want to get maximum contrast possible. You want to create a bitmap in memory, scroll through the entire play area and render this out as a finished PNG or something like that. The code is kind of logical. It's all there in the project. So we're going to, I'll give you the links for this afterwards. Go and have a look at. This is portable to anything that lets you build a bitmap and render it. And what you end up with is a reusable template that drives the control net that locks perfectly to your level that you've designed. So the last bit is to bring that level map into ControlNet. Here you just literally upload it, you enable ControlNet, pick the pre-process you want. You see soft edge, scribble, canny, etc., line art. super important where that arrow is. If you don't hit that button, this copies the dimensions of your level into stable diffusion and sets a high res fix if you need it. Without that, you will not have any results to speak about at all. Other things to mention is that you can chain these pre-processes together as well. So you can start off with something that's much looser, like a scribble, and then put it through canny edge detection and bring it to a much finer pixel aligned result. Reason that's interesting is because if you get flat surfaces, it really brings depth to them. Anyway, as long as you you can explore with these. You see the starting control step and the ending control step. If you add more and more pre-processors, you want the control steps to line up but not overlap, and then you can chain them together successfully. And finally, generate your background levels. And you see here, red things, that's the imported size of our tile map. I'd say get a batch size of something bigger than 1, because not everything will be a good candidate. You will throw a lot of them away. Use positive prompts, use negative prompts, etc., and off we go. So I'm just going to do a quick walkthrough of what we've got. So if we're in Godot, let me just drop out of here. Cool. This is going to be interesting. There we are. Okay. So you can see there we've got a tile map, nothing particularly inspiring. If we go over to here, we'll just add a new little tiny set of something onto it, add a new level so we can actually jump to something that we couldn't reach before, and we'll just paint. This is none easy. Okay, that looks better. Cool, so just added a new level in there very quickly. If we go up to the project, we're going to put it into rendering mode where it renders out the tile map and have a quick run of it. So we render things out. And all we're doing is setting a command line flag on that. Put it into render mode. Let's close that off. And hit F5. And you can see it just runs through everything. And we end up at the end of the day with a template to upload to Stable Diffusion. So that's the next bit. Let's do that. Okay. Here we are. And we're here in Stable Diffusion. Now, so this is the automatic 111 web UI. This is the control net part. So we're going to upload here from our generated template. That one there with the new tile set just there in it. We're going to enable here. We're going to do pixel perfect, set soft edge quickly, and then hit that button up here. So now we've got our dimensions up here. Has anyone got a good theme to go and generate for a game that they have at the top of their mind? Anyone want to chuck anything out there? I had a very weird 3 bar dreams last night after drinking lots of beers, and so I'm thinking Hieronymus Bosch, maybe. Should we go? What's that? Sugar country, Sugarland, Sugarland. Okay, Sugarland. Interesting. Okay. What's some other words for sugary stuff? Yeah, cool. Okie dokie. What's that one? What's ink and fluffy? Oh, fluffy, pink and fluffy. Sorry. I thought that was an HR moment for a minute. Pink and fluffy. Okay, cool. All right. Let's see what happens. So, no idea. Like, you do your first thing and then you sort of refine it and work and go. But you can test something like this that would normally take, I don't know, like days and days and days to go and work out with different ideas, prototype stuff, throw it away, put it back in the bin, talk some more about it, try some different things. And here it's going to take a couple of minutes maybe, and we're going to get 4 candidates of potential things that should line straight in. It might work as a concept, it might not. I don't know, we'll find out. I like the idea. Oh, dessert. Did I put desert? Sugar desert. Yeah, there's worse places to be, I think, than a sugar desert. I think.
It will be sugar halal.
So I generated a whole ton of, interesting, getting there. I generated a ton of levels and different themes, and in a minute there's a QR code, you can go and play it on your phones and whatever, unless you've got an iPhone, because there's a bug in the shared buffer array with Safari at the moment, but anyone else, you go play this and see how quickly you can generate. Like there's Meat World, there's Skin World, there's some very weird worlds out there for you to go and run around in and see what you get. Okay, so we get initially a preview of things. That number there is the seed number, and if you like what you've got, by the way, this is a very important number because that seed will pin the noise generation, and then you'll get the same images for the same prompt, and you can start really tweaking things as you want. So pay attention to that seed number. So we get always, let's work backwards actually, because we do it. So that's it through the filter, right? This is the pre-processed step, and that's what you get. Here's our overview of the 4, so you get like a shot of the 4. And there's Candy Desert. Yeah. Okay, so let's go pull one down and run around. Which one? Tell me when to stop. That last one? Oh, this one. Okay, deal. So that's that one. So let's go download him. Okay. So then we're going to just take that and drop that into a folder where we're loading random images all the time, right? So I've got a GIC folder, so I'll just do it on this screen because it's a bit quicker. Yeah, you. GIC. Okay. Let's get rid of a few of these ones. So, okay, we've got 4 random images in this folder now. Let's go back up to here. I did a little thing this morning just to make things quicker because the demo up there has maybe 50 different images. We're just going to load one theme. I'm just going to load that one. I just need to turn the render off. Cool, good enough. Let's see which screen we're on. Okay, loading complete. Okay, we're straight in there. So the idea is you run along and you can go up and down ladders and the rest of it. I've got joystick turned on as well. You get to the end, and you go through a door and you get into another world and off you go. It's not the most exciting game in the world, but you can see how quickly you go from picking up an idea and going, actually, does that work? And it's like, yeah, do you know what? Candyland could work with a little bit of laugh. And there's all kinds of tips that I'm just going to go over quickly to make it more successful for you and give you links to all of this stuff. But yeah, that's kind of, you can bring something in that fast. So, demo done, where are we at? This one. Cool. So back up, yeah. Tips that you found, you can chain control nets. So if you start from a pre-existing artwork, you could put it through like the segmenter preprocessor, and then from the segmenter put it into soft edge, and you can chain these together. So you can bring not necessarily a custom tile map, but anything you want in. And to enable more than one, this is the steps to do it, settings control net in the automatic 111 UI. And go from the widest to the narrowest, go from the fuzziest to the most precise at the end of it. The fuzziness will bring out depth in things, but you want to end up precise so you're pixel perfect, so everything aligns, especially if you're doing like hardcore platformers. And this is the same thing, set the control steps, so you have a start and an end point of when each preprocessor affects in terms of a percentage of the whole flow. If you've got 3 control nets, do 33, 33, 33 and offset them so that they don't overlap. Use semantic segmentation, just talked about that. You can add a refiner to the style as well. I'm not going to go into that too much now, but you can add a checkpoint that pixelates everything. If you actually want hardcore pixel art idea, you can add a refiner step at the end that will take that Candyland image and then put it through a pixel processor and turn it into like full-on pixel art kind of style to see if that works. And it might be like, no, it doesn't, or whatever. Same seed, same prompt. This is super important, gives the same result. And you saw where to find the seed. For generating templates, use TileMap layers. I can't say this enough, like the static stuff, put it in the background layer on the TileMap. And only generate a template with the static segments, not any of the moving stuff. Put a hard black background of a color X or anything like that. Modulation, I think this is super interesting. This is why the layers are interesting as well. So I picked up a demo project that was like a CCO project. It's linked to later on and in the README. Pulled it apart quickly and pulled the door out and pulled the player out of the tile map because I wanted to modulate them. And what I mean by that is you can go through your tile map, find a random bunch of tiles. I ended up just sampling 5 tiles, seeing what the current artwork principal color was, and then taking the inverse of that for my character and my door so it always stood out. So if you're generating things completely dynamically, you want to do something along these lines to make sure that your characters aren't the same color as the background, because it's just going to get lost in the noise, right? Use pixel grid snapping always, viewport, put it in stretch mode. Experiment with block filling in closed areas as well, like at the bottom of the level, there was the steps, they were block filled. Initially they weren't, and I spent ages trying to force interesting things to happen in there. Block fill stuff, and don't be shy about block filling with pattern things or not pattern things, and choose your random tile sets. And keep tile sets very simple. A couple of things, if you're doing stuff in AWS, so that Stable Diffusion was running on a G5 up in AWS because this is a small AMD thing. Use a G5 2x for automatic, and you can you can publish to the web and bang it straight into S3 bucket as a website, put CloudFront in front of it as our CDN, and just set those headers, and you can publish straight from Godot into a free cost. You'll be on the free tier if you do that. Website to host your game as well, just a little thing. In the project that's linked there, you'll find all the scripts for doing this. There's a script for setting up EC2 instance with automatic 111 control net, stable diffusion, the QR codes, the game if you want to play it and run around lots of different weird lands and look inside my head a little bit. And thank you very much for that. Thanks.